Cool. So we left off on Thursday on part of study unit 9 with our hypothesis testing. So before we go into our hypothesis testing, there was a question on the chat on confidence levels and if you look at the confidence interval, those kind of things. So what I thought I want to, and this is something that I've seen in assignments and in exams. So so basically what I want to show you guys is what they can ask you about, and I'll rather change this before I send it on to talk to specifically confidence intervals. So remember the confidence interval in study unit 8. It looks something like this, and there's one for proportion as well, but let's not worry about that for the moment. So basically we have three things that can influence that confidence interval. Okay, so, and I just want to get that table that we also used. Okay, because this will also be nice just to show you. Okay, so there's three things that can influence this. So if we, and a lot of the questions will say, but if you change the confidence level, what will the impact be on your confidence interval? Or if you change your standard deviation, what will the impact be? If you change your sample size, what will the impact be? Okay, so the one thing nearly to look at is, so let's first do the confidence interval, the Z. So the higher the confidence interval, so if we go from 90 to 99, the higher the confidence interval, the higher your Z becomes. Okay, so if we increase confidence level, we basically increase Z. So if you go from a 90% confidence interval to a 99% confidence interval, your Z will become bigger. And so if everything else in this stays the same, if Z becomes bigger, this part of the equation becomes bigger. So if that was 20, originally say this was 10, we make the confidence interval bigger. Now let's say it is 15. We will see that confidence interval will increase. So where it would have been 20 plus minus 10, now it is 20 plus minus 15. Okay, so nearly the first thing is that if we increase the the level of confidence. If that increases, we increase the Z, and by increasing the Z, we basically increasing the gap in the confidence interval. Okay, so that's one way of that they can ask it to you. Let me duplicate the slide. Okay, the Z. Okay, so now let's just quickly want to erase some of this. We can do the other one because this is something that you will get if you're not getting it in the exam, you will definitely get it, or if you don't get it in the study assignment, you will definitely get it in the exam. Okay, so let's keep that exactly the same. So, and let's stay with that x is 20. Okay, so we dealt with a z. Okay, so now we say, okay, we don't worry about the z. We know what that influence is. So let's look at your standard deviation. And again, I just want to use simple numbers. So if my z was originally 1, my standard deviation was originally 5, my n was originally 25. I'm just making it very easy for myself here. It would have been 1 times 5 divided by 5, which would have given us 1. Okay, so we haven't changed anything yet. So that would have been if that was the numbers that I've gotten. So maybe they tell you then in the assignment or in the exam that your standard deviation is increasing from 5 to 10. And what does that influence now have on your confidence interval? So let's look at that. So instead of 5, it's 10. We divide still, n was kept the same. So that was still divided by 25, which gives us 10 divided by 5, which gives us 2. Okay, so now with the increase in standard deviation, we can see the increase in that standard error that we have. So we will see an increase in your confidence interval. So when standard deviation increases, that will mean that your confidence interval will increase. Okay, so that's nearly the second one is if standard deviation goes up, your confidence interval will go up. If standard deviation goes down, so if we set that our standard deviation was not 5, it turned into 1 maybe, then it would have been 1 over 5, which is 0,2. 0,2 would have then been smaller than the original of 1. So when standard deviation basically go down, the confidence interval will go down. Okay, so we've now nearly looked, and I know it's a lot to take in, so that's why we also record it, and you can go through it again, and in the next session we can discuss this again. I nearly just want to give you tips for now if something like this does happen in your assignment. Okay, so then the third one that we need to look at is, so the third option is what happens with n. So if your sample is being changed. Okay, so let's see if we can quickly just do all of that, take it out. Okay, so when confidence confidence increased, we were happy. Your confidence interval will increase. When standard deviation increased, we were happy that your confidence interval also will increase. So the last thing to look at is what happens if we change n. Okay, so let's again make it the simple one where we had 5 over 25, and we had that as 1. So the original one was that. So let's say we increase n to 100. So if we increase n to 100, all the other stays the same. Increase n to 100. Standard deviation of 100 is 5. So we sit with 5 divided by 10. So now you can see that your confidence interval will become smaller. Okay, so when n increases, confidence interval becomes smaller. So basically, we have two scenarios. If z or your standard deviation increases, your confidence interval increases. Where your n increases, your confidence interval decreases. And then the opposite is also true. So if z decreases, confidence interval will decrease. If standard deviation decreases, confidence interval will decrease. If n decreases, confidence index or confidence interval will increase. So the opposite is also true. So I've seen in a previous exam where they said keep everything the same, but you've got a 90, 95, and a 99 confidence level. What will that have an impact on your confidence interval? So I just wanted to add this part to our session today, because it might come up. And it's not something that I think it's really covered in any of the study guides or any of the textbooks or anything like that. And about 3 years ago, they started really introducing these questions into the into the exam papers as well. So when we look at confidence interval, I just want to say, because that is the things that will impact the confidence interval. I just want to change it in all of these so that afterwards when I send it on, you guys can also look at it. So please, if there is questions like this coming up and you want to understand a bit more around it, please ask. I think that's important that there's certain things that I've seen that is not really explained in detail in the study guides or even in your textbooks. Um, so please, if there's anything like this coming up again, ask, and we can nearly go through it in one of our sessions, because I think it's easier to explain it like this than how I would have tried to explain it on WhatsApp. Okay, so that for me is the three things extra just on the confidence interval. So let's first stop and ask, are you guys a bit more happier with this explanation? I don't know if it did came up in the assignment yet, but if it's not in the assignment, it will definitely be in the exam. Okay, cool. So let's then continue with the rest of study unit 9, and let's finish that. Okay, so last time we looked at the hypothesis testing. We looked at it when we were looking at the Z that was around the mean. The last three questions is again looking at hypothesis testing, but around proportions. And again, nearly they can, it feels to me this might be more a question like question 3 that they might ask you, because again, this looks at the totality of the work. So a question like question 3 sums up everything that you need to know about something like study unit 9. Okay, but let's just do the others, and again we'll see I copy this table in everywhere so that it is, and you again open book, you're allowed to have this available. You basically, and I want to reiterate it, you're allowed to use any means in your exam except another human being. So if you have access to 20 devices with calculators on and things like that, it's fine. You can print all my notes, have it with you. You can print all of these PDFs and videos and things like that. The big problem just in the exam is always it's time. Okay, so let's go to this one and let's see how we need to answer it. So always when I look at a question like this, my first thing that I want to identify is it a one tail or two tail? So last week we already identified it as a one tail. The reason why it's a one tail is because your alternative is showing just one direction. Okay? One direction means it's one tail. Okay, so let's look at what they've been asking us. So we need to calculate the p-value of a test of a following hypothesis given that the sample proportion is that, n is that, a calculated z, tz is that, the null hypothesis is the following. So basically, what they are telling us, oof, that is a terrible representation of a normal. So we know that that is 0. Look at that. They tell us the calculated t stat is 0.05. Okay, so let's work it out there and then just see if, because if you've missed that, again, there's time that we are wasting. But I want us to do it because, again, just important in what is happening in exam papers. So I think with the assignments, it is now already nearly fine that we get that most of you guys are more likely to complete the assignments in the allotted time frame. Okay, so if we now calculated that, it would have been on the top 0.03. So at the bottom, it would be zero point 0.6 times 0.4. We divide it by 100. We take the square root of that. That would have given us 0.0490. If we then divide the one by the other, let's quickly see why. Oh, it is n. So have I done it now correctly? That's strange because that and that answer should be the same. So let me just see where I made a mistake. It is 0.63. It is 0.6. That is correct. That times that. 0.6 times 0.4 divided by 100. And that is interesting. I'm getting a different number here, which is strange. It should not be like that because what they are now giving us is they're telling us the Z is 0.05. Okay. And they want us to work out that p-value. So that for me is just interesting. That should actually be the same. That answer and that answer should be the same, but okay. Let's just, we'll double check that again. Let's just go to the tables. Let me get table across. It is slow today. Definitely paused it already. T. Okay, so they said to us the Z is 0,05. So let's first do it on this graph, 0,05. And because we're using the positive, it fills that area. So 0,05. So 0,005. So it's 0.5199. Okay, so 0.5199. You would see that that is one of the options. We're not looking for that space. We're looking for the p-value, because the p-value says to us it should be bigger. Okay, so we're looking for the bigger. If it was smaller than, that would have been your area. But we are asking for bigger, so we want that area. Okay, to get to that area is just 1 minus 0,5199, which then is equal to that. My biggest concern with this is if this was calculated, we should have gotten the same answer. So obviously what they did with this is they used it from a previous exam paper. They changed some of the numbers. They probably changed that, but they didn't remember to change some of the other numbers. But if we've done this calculation, we should have gotten that 0,05. So I'm just, again, wary that they probably used some previous exam paper. But what I wanted to show you here is, here they are giving you what you need to work with. And sometimes we're so programmed that we're like, okay, we get that, we have that, let's work it out. And in this instance, they actually told you what the t-stat is that you need to work with. Okay. Be careful with the p-value, because like I said, so this is 0,05. If they told us we're working with Z smaller than the 0.6, this would have been the p-value, and then it would have been 0,5199. If they said, like they now did, bigger, that one is the p-value. So again, just be careful when you look at this, and when they talk about specifically working out a p-value, then you need to definitely take into account the direction of the hypothesis. Okay, so let's go to another one. So here they basically still give us information. Let me just put this yes, because again, I don't remember this. You don't need to remember. You have it. This you don't need to remember. You have it, and you can see my son have played with my with my color pens again. Okay, so a popular weekly magazine asserts that fewer than 40, okay, fewer than 40. So I think again important, fewer than is less than, of households in South Africa have changed their lifestyle because of escalating gas prices. A recent survey of 100 households finds that 70 or 67 households have made lifestyle changes to the escalating gas prices. Okay, so 67 divided by 100 give us 0.67. Okay, so we have here the alpha and there we have the P. Okay, so let's see what they ask us. Which of the following is incorrect? Okay, null hypothesis is always equal to. Um, uh, so null hypothesis is always equal to. Okay, so that is fine. That is how it's going to be. Your alternative is then opposite. So what do they tell us? Fewer than, smaller than, perfect. Null hypothesis is that, it's that, correct. Okay. So if they ask in here, if we're working with a one or two tail, that direction tells us it is one tail. So if they had it somewhere in one of our options, it is one tail that we're working with. We need to work out the T-stat. We need to find the critical value. So let's see, 10%, 10%, so 90, 100 minus 90 is for 10% alpha. We can actually, if we put in here, we can say the alpha here is 10%. The alpha here is 5%. The alpha here is 1%. Okay, so we're looking at 10%, so we know it is this one that we're looking at. We know it's one tail, so we're not working with that. We're working with one tail, so it is 1.28, which is correct. Okay, so again, what you will see is for me, it's nearly, I like to work with a process. So you nearly step by step can identify, and I would, if I look at, okay, I haven't have another one like that, but that is nearly what I would do in the exam as well, is I would look for the easiest nearly. So I would look for one or two tail first, then I would look for the hypothesis somewhere, then I would look for the critical value. Yes, if all three of them are correct, then you go into more detail. but I won't start with a T-stat that I need to calculate first because again, it it does take time. Even if we use Excel, it does take time. So let's work it out. That just looks a bit. And we divide it by feels like nearly the same set of numbers that we used for the previous one. Okay, so at the top we have 0.07. At the bottom, let's quickly work it out. So it is 0.4 times 0.6 divided by 100, and the square root of that would have given us 0.049. So if we divide that by that, why do I again get a different answer? There's definitely something wrong with my calculator. Let's just open a Excel spreadsheet just to and so let's say equal, we know it is 0.67 minus 0. Ah, there was my mistake. Should be minus 0.4. Okay. So that would make a big difference. I used 0.6 instead of 0.4. Okay. Easy again to make that mistake. Which I did, and that can influence your whole answer in the end of the day. Okay, so then if I do that divided by that, 5,51. Okay, so definitely that is correct. I just want to change that because that is where the problem came in. And that's why I said it looks very similar to this one. It didn't. Okay, so just by some small, to change small thing, you can see how easily it is to make make that mistake. Okay, so 1 is right, 2 is right, 3 is right. So let's look at option 4 and 5. So let's just, where was, I want to get that one that I did last week because I think this is such a nice, I just want to see if I've done it a bit bigger. we will just do a bit of changes here. Okay. Okay, so we've got our normal distribution. Then what is very important, and I will put this part back on the WhatsApp group again, is nearly, let's do that. We can take the other one away now. But if your test value is bigger than your critical value, we basically reject range 0. If your test value is smaller than your critical value, we accept H0. So what I can also now say is, instead of rejecting H0, I can say accept the alternative. Instead of saying accepting H0, I can say we not regret, we reject the alternative. Okay, so I think it's important nearly to this part for me is nearly critical. And yes, you can have this with you again when you write the exam. So let's see. Let's take this part out. Let's see what did they give us. What did we work out? So the T-stat that we worked out was 5.51. The critical value was 1.28. Okay, so somewhere here is a critical value of 1.28. Somewhere here it is the T-stat that we worked out. T-stat bigger than your critical value is we reject the null hypothesis. Okay, so if we go back, conclusion, H0 is not rejected at that level. No, we are rejecting it. We are not rejecting the alternative. So again, we are rejecting H0, so it is wrong that we say we're not rejecting. Okay, so this is the incorrect one. To work out this p-value is, again, it's a difficult one because you would see on your tables, we stop at 3. And at 3.09, you would see so let's go to the negative one because the negative one shows it nicely. At 3.09, we're sitting with 0.001 for that small area. So this small area, I've now made it look very big, but this is really going to be so small. You can check on a Z calculator online that your p-value is going to be so small. So that's why your p-value equals 0.0000, and it's only nearly on the 6 or 7 zero that there will be a 1. So assignment wise, you can have it that they go into the higher T stats that they give you, but in the exam it will probably be limited to something 3 and less, so that you are able to use the tables for that, because it's, yeah. So if you go and search onto the internet and you say calculate p-value from a Z distribution, you will be able to put in 5.5102 and you will get what the real p-value is. Okay, so we've covered this. I think this is quite important. And then the next one is where they do a lot of I don't want to say silly things, but word construction that's important. And again, I personally hate this because again, English is not my first language. So to really understand, okay, what are they saying? To reject H, to not do this, to reject that. So let's just go through it. So in testing the hypothesis at the 5% level, if that is needed, at the 5% level, one tail is that one. So if we use this example, my critical value is equal to 1,645. Okay, so that's my critical value. Yeah. Copy this slide over because again, please, you guys can also use this slide nearly. So critical value we've seen now is 1,645. Okay, we need to calculate what the t-stat is. Okay, so t-stat, gonna use that. So it is P, did they give us the P? Oh, well, they already give us the p-value, which is also interesting. Okay, but let's okay, so this is quite interesting. So I give us the critical value. They tell us at the 5% significance level if a sample proportion is that. So we know that that we know that P is equal to 0.45. We know that that is equal to 0.4. Okay, so one tail. So this is now a bit different. Sure. Okay, so this is a bit different. So we still have all of this information. We just need to do it the other way around. So it's good that we do this one now. So they told us we've got our critical value of 1,645. Okay, they've given us that. We need to find out what is the t-stat. Okay, so what we need for t-stat is we've got the p, we've got that nowhere here is an n. Okay, so nearly the logic says to me, I need more information because I don't know the n. Okay, which in your exams, it will never be you need more information because there will be something else that's hidden in the question. They give us the p-value. So they tell us that that p-value is 0, let me just write it down, 0,0764. So they tell us the p-value is 0,0764. So I'm going to draw it there. I really don't know where. Let's draw it somewhere. Let's draw it somewhere there. So they tell us that this area is 0,0764. Okay, so we can actually work out what the t-value should be. Okay, so we can work that out. So if I need to work out that area to use my table, is 1 minus 0,0764. So now we're going back to study unit 6 and 7. 1 minus 0,0764 is equal to 0,9236. Okay, so let's go to our tables and see if we can get a value for that. So 0,9236 0,929236. Okay, so 0,9236, so 1.4, 1.43. Okay, so your t value is actually 1.43. T value 1.43. Your critical value 1,645. T value smaller than critical value accept the null hypothesis, or we reject the alternative. Let's look at the options. Reject, no. We said we accept null hypothesis or reject alternative. Do not reject, that is exactly the same as accept. We reject the null hypothesis. It's just the alternative. We reject the alternative. Okay. So that is your correct answer. Can that be? Let's quickly see. Reject. Sorry, I'm just looking now at the wrong diagram. Okay, 1,43 was smaller than 1,645. Accept, null, reject. Oh, this is quite interesting. Not to reject null hypothesis. Not to reject null hypothesis is accepting the null hypothesis. So here, again, is a mistake because those two are exactly the same. If you do not reject the null hypothesis, you do reject the alternative hypothesis. Just a marker on here. So if we look at this, this is clear that there's a mistake because, again, that's why I hate these questions, because now you can see with their own English that they used, there's a mistake, because that is exactly the same. Not to reject means that you accept it. To reject is you reject it. So both of that is correct. Oh, I hate it. So if, again, assignment or exam, something like this pops up, please don't hesitate to send me a note on it. Really, really, I think it's important because this, we've done a lot within the stats department to correct these kind of things. These textbooks are nearly in running for the last 5-6 years. So you the last guys that will work with a current study guide and assessment or assignment, extra assignment questions from next year. We are actually working with the lecturer on a new study guide and things like that, to make sure that these errors doesn't come into play anymore. But please, if there is anything like this in your assignment or exam that it actually says exactly the same thing, please report it. Because then I will just send the lecturer a WhatsApp to say, I think there's been some of the students are complaining about question 12 and they think there's an error. So please do that if you go through, especially now assignment 4 as well. Okay, guys, this has been the end of this study unit. So study unit 9 on proportions. Next time we'll start with study unit 10, which is your chi-square. It is going to be also